Now we are going to go over the workbook pages. I'm starting on workbook page 159, Prisms and Pyramids. So it's asking you to identify the type of prism and the shape of the faces. So when we look at this, we can tell that this is a triangular prism. And we know that because two of its faces are triangles. And so that means the two bases are triangles, because we know in a prism that two of the sides have to be the same, have to be congruent, and we define the prism by that shape. So in this case, this is a triangle and this is a triangle, so it's a triangular prism, and the other three sides are rectangles. And that's the other characteristic of a prism, is that two of its faces, which are the bases, have the same, and then the other sides are all rectangles. Okay, so in this case, we have a rectangular prism, and that's because all of its faces are rectangles. Or you could think of it this way. You can think, let's say that we make these two sides the bases, this and this. We could make any two sides the bases, but just to help you think of it. So if these two sides are the bases, then that makes it rectangular because they're both rectangles, and it makes it a prism because all the other sides are rectangles, and that's a characteristic of a prism. Okay, so moving on to the next page, this is where we are asked to fill out a chart telling the number of faces, edges, and vertices. So when we look at this, we're looking for, first of all, the type of prism that it is, and these are both trapezoids that are the same and congruent, so this would be a trapezoid prism. So let's count the number of faces. So we have 1, 2, and then the rest are rectangles, 3, and then this one would be 4, and then this one 5, and the one on bottom would be 6. So 6 faces. The number of edges, 1, 2, 3, 4, 4 on top, another 4 on the bottom, and then 4 here, and then, hold on, you know what, we've double counted, so let's start again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 edges, and then the number of vertices, we can put little dots on those. 2, 3, 4, 5, 6, 7, 8. So 8 vertices. And so in this one, we have a triangular prism because our two bases are triangles. So the number of faces would be 1, 2, and then we have this side, 3, 4, and then we have this bottom right here. So that would be 5 faces. And then the number of edges, we'll just count the edges, the place where the faces meet. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And the number of vertices, it's like the number of corners, put little dots there. 1, 2, 3, 4, 5, 6. 6 vertices. Okay, so looking down here at the last one, our two bases that are the same is a pentagon. And so that means this is going to be a pentagonal prism. So let's see how many faces. So we have the two pentagons, that's 1, 2. And then we have the other faces, which are rectangles. Remember, in a prism, the other faces are always rectangles. So we had 2 here, and then 1, 2, 3, 4, and then this top one. So 5 rectangular faces, 2 pentagons, for a total of 7 faces. And then edges, just going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So 15 edges. And then vertices, or the corners that we can put little dots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 vertices. Okay, so now we're moving on to pyramids. And we know this is a pyramid because the sides are triangles and they all come together to form this one vertex at the top. And we know it's a triangular pyramid because the base of it is the shape of a triangle. But like I said, all its faces are triangles. So all these faces are triangles. Okay, so this one is again a pyramid. We know immediately that it's a pyramid because all the sides come together to form this one point at the top. Think of those Egyptian pyramids. So one of its faces is a square. The base of it is a square. And we know it's a square because these little notches tell us that all the sides are equal. So because the base is a square, it's called a square pyramid. And the other 4 faces are triangles. Okay, so let's come right here. We're going to do the same thing that we did with the prisms. We're going to see if we can figure out how many faces there are on each of these pyramids. So this is a pentagon at the bottom. So it's a pentagonal pyramid. So the number of faces would be 1 would be the pentagon at the bottom, and then 2, 3, 4, 5, 6. There's 5 triangles going around. So 5 plus the base would be 6. And the number of edges would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the number of vertices would be 1, 2, 3, 4, 5, and then don't forget the one at the top, 6. Okay, so let's look at this one. This is 1, 2, 3, 4, 5, 6. So a hexagon at the bottom. So this is called a hexagonal pyramid. We know it's a pyramid because all the sides are triangles, all the faces are triangles, and they come together to point at the top. So let's see how many faces there are. So we have 1 at the bottom, which is the hexagon, and then we have 6 triangles, 6 faces that are in the shape of a triangle that go around the sides. So that would be 6 plus the 1 at the bottom would be 7 faces. Then how many edges? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then how many vertices? You can just put little dots. 1, 2, 3, 4, 5, 6, and don't forget the one at the top to make 7. So finally, these are nets. And what we're doing here is looking at these nets to see if we can figure out what shape they form. So this one is all squares. So the only thing that could be is a cube, or we can call that a square prism. This one we can tell has one square and the rest of the sides are triangles. So that immediately tells me it's a pyramid, but all the faces but the bottom one are triangles. So I know it's a pyramid. You can imagine bringing each of these sides up and they'd form a pyramid at the top with a square at the bottom, so that would be a square pyramid. This one is kind of tricky to see. For me, I just looked at it and I said, okay, I know it's got to be something triangular because all the shapes are triangles. There's no rectangles there, so I know it can't be a prism because a prism, the faces are rectangles. And so almost by process of elimination, it has to be a triangular pyramid. And this one, kind of same idea. I know it can't be a pyramid because not all the sides, not all the faces are triangles. So I know it's got to be a prism of some sort because we have rectangles here, and that's what forms a prism. But I have these two triangles. So that must be my bases, and so it would be a triangular prism. And then in this last one, we know it can't be a pyramid because we don't have any triangles. So we know it's got to be some sort of prism. And you really could call this a square prism if you wanted to, because you could think of these squares, assuming those are squares, could be your bases, and then you'd have a square prism, but I don't really like to think of it like that. I like to think of it as a rectangular prism because I don't know for sure that these are squares, and everything is a rectangle. So because they're all rectangles, a rectangular prism, I think, is the better answer. Your book says square prism, and I think I see why they do that, but I think the more accurate answer would be a rectangular prism.